Assalamualaikum. Hi guys. In the previous video, we've learned how to calculate the energy of an electron in specific level by using this formula. And the next one, you also learned how to calculate the difference in energy between two energy levels by using delta E formula, and you substitute the value based on n value, which N1 can be your N initial and N2 will be your N final. So you will have this value inserted here. And the next part, you also learn how to calculate the energy released by the electron using delta E equals to HV. And by using the frequency formula, you can insert into the formula of delta E for frequency, you will have another formula. And this is what we use to calculate the energy released by the electron that is same with the difference in energy between two levels. So these all are what you've learned so far based on previous videos. I also taught you how to differentiate between continuous spectrum and line spectrum, but in this case, starting from here, we are going to focus a lot about line spectrum. I'm going to recap a bit about the line spectrum of hydrogen atom. You have to know that when an electric discharge passes through a discharge tube here, which containing the hydrogen gas at low pressure, the emission spectrum or line spectrum can be produced. So when we examine with a spectroscope, the light emitted by the hydrogen is found to contain separate sets of line. You can see from this picture, you got separate sets of lines. Each set of lines is called a series, and each line in the series corresponds to the light of a particular frequency or wavelength. And you need to find out the value for frequency and that wavelength later on. Right now, we are going to focus more about these sets of lines. So as I mentioned before, you have a set of lines, what we call as a series, that can be produced when examined with spectroscope. So this is how you will get the formation of the line spectrum. You can see that you got different series because different sets of lines. For example, this is the first series, Lyman series. This is the second one, Balmer series. And this is the third one, the Passion series. So in each series, the differences between the wavelength or frequency of the lines become smaller. You can see from here, from the first line here, until here, the lines become smaller and smaller towards the end of the spectrum. That is towards the low wavelength and high frequency of spectrum. So you can conclude here, more towards to the right, the wavelength increases and frequency decreases. So this is the relationship between the wavelength and frequency based on different sets of lines. So this is the keyword that you have to know. It is referring to the same thing. Sets of lines equals to series. Basically, you are going to learn 5 different series, but I just introduced 3 with you right now. We are going to learn more later on. Let's go to the formation of line spectrum. The first step, when you have the energy level diagram, this is what I have here, my energy level diagram, where I'm going to start with the first energy level, n equals to 1, until n equals to infinity. The energy increases. This is where you have the atom, where the energy is absorbed by the atom. That causes the electron to move from lower energy state to higher energy state. This is what we call as the process of excitation. At this part, the electron will not remain at the high energy level because it is unstable. It will fall back either to the level from which it started or to some intermediate level. So this is where your electrons are going to fall back to the lower energy level. For the first transition, you have n equals to 3 to n equals to 1. For the second transition, n equals to 4 goes down to n equals to 1, and so on. In doing so, electrons will lose an amount of energy exactly equal to the difference between two energy levels. For example, I took the green transition, so there is energy difference at this part. And after that, this energy will be emitted as electromagnetic radiation of a certain wavelength and produce a single line in emission spectrum. Thus, the return of excited electrons to the lower energy level here results in emission of photon. Photon here is referring to the light. So this is the general explanation how the formation of line spectrum based on one series. However, I talked about different series before. For example, we take Lyman series. Lyman series is the first series that we can see based on its ground state n equals to 1. So you can see that all transitions here, you have 4 different transitions based on emission of photon. All of them share the same ground state or the same lower energy level, which is n equals to 1. So this line spectrum is going to start from right to the left, but it can also start from left to right. It depends on the question given. So from here, you can see that when towards to the right, the energy decreases. However, the wavelength increases. And you can see 4 different transitions here. We are going to call the first line, the green one, as first transition, the blue line, second transition, purple, third transition, and the last one, fourth transition for this orange line. So that's why you have to take a look at the question that you got, whether it is specific which series it talk about. That is why I'm going to introduce to you 5 different series here, starting from Lyman series, n equals to 1 for its lower energy level. When n equals to 2 for the lower energy level, the Balmer series will form. Next one, you will have Paschen series where the lower energy level is n equals to 3. Bracket series for lower energy level n equals to 4. And last but not least, Fun series is for the ground state n equals to 5. So I'm going to put this series in one table so that you can differentiate between each of them. You can say that there is a specific name for this part, which is, I'm going to introduce to you how to memorize this series as Lyman balik pasar beli pisang. You can use this acronym to help you in order to memorize this series. The next part, you can see a different n values for the first energy level for different series. And then, of course, different N2. This is for the higher energy level. The next part you have to understand is the spectrum. When you have a spectrum region, for Lyman series, it will exist in ultraviolet region. The next part for Balmer is the only spectrum that is visible to the unaided eye. And the last 3 series here, Paschen, Bracket, and P-Fine, they are all in the infrared region. So this information is very important for you to understand about formation of line spectrum when you answering the question. So I'm going to explain a bit more about the formation of each transition. let's consider Lyman series as our first choice. So what you have here, this is the energy level diagram for Lyman series. I'm going to draw the y-axis is for my energy, and the next one, I'm going to transfer all the information from this energy level diagram into line spectrum. So you can see that from here, you have the first transition where your atom absorbs the energy. It will excite to the higher energy level from n equals to 1, excited to n equals to 2. However, at this part, the electron will not remain stable. It will fall back to the lower energy state and emitted photon. So this is why you got the first transition, the blue line. The blue line only can be formed once the electron fall back down to the lower energy state. It will not form yet at the point when electron absorb the energy. So please make sure you understand that concept. Next one, we focus for the second transition when arrow pointing up. So from n equals to 1 to n equals to 3, this is going to be my indicator that electron absorb energy. So it will excite to the higher energy level from lower energy level. But same case as before, at this point the electron is very unstable. It will fall back down and you will have the second transition for the line spectrum here. So this transition is to indicate from n equals to 3 to n equals to 1. Next, you have the third transition, the green one. For example, I have from n equals to 1 to n equals to 4. It will fall back down to the lower energy state once it is unstable at this higher energy level. So you will have the third transition here. And last but not least, if I continue to further my electron absorption, it will go to the next higher level, n equals to 5 from n equals to 1. And at this point, the electron is unstable, fall back down and release photon. Then you will have the last spectrum here. So if I stop here, you only got 4 different lines to indicate 4 different transitions. But if you continue until the next and the rest of them, you have to make sure that it will fall back down to n equals to 1, this ground state or this lower energy level. Why? Because we are focusing on Lyman series. Ground state should be always n equals to 1. So let's consider, based on the information that you got just now, you are going to know that the first line here for the blue one is indicating where the electron fall from n equals to 2 to n equals to 1. So from the second energy level to first energy level. And you can see also for the second line, third line and fourth line, this is all the values starting when the electron fall back down to the lower energy level. So this is going to be n initial and this is going to be n final. And as I mentioned before, the ground state for Lyman series, the ground state or the lower energy level for Lyman series will always be n equals to 1. But the difference only for the energy level where the electron fall from. So I hope you can understand how the transition for each lines of specific series can be formed. That's it for this video. I'll see you in the next one. Bye!